Alrighty, and we're live. I'm just going to test YouTube, make sure that we're live. Hello to everyone if you're out there. Hopefully this is streaming through to YouTube, both on the Lilypad Twitter, YouTube, and on the Filecoin YouTube. Is it though? Yeah, so it definitely is. Awesome. Verified. That's what we like
It's working.
in distributed computing, verification, right?
Right.
Anyway, hello, hi everyone. Happy holidays. Thank you to everyone for tuning in from wherever you are. Drop us a note in the chat. Let us know where you are at. It's summer here in Australia, so the palm tree on this slide is actually relevant to me because it's bloody hot. I'm sitting in a apartment block. It's all glass, which is amazing for views, but it is a glass house in summer. I feel like I'm about to start sprouting or something. Anyway, happy holidays to all of you. You can have some of my sun for your winter over there, probably. Anyway, what are we doing here? Logan? I'm Ali, super excited to be sharing more about Lilypad, which is a project we've been working on for the past good half year or so now, and you can use it for your AI, ML, and other compute jobs today now. I'm also joined here by Logan, who has been helping out on the project. He's a legend, and who's going to show you how you can make your own custom Lilypad compute job today as well. Hi, Logan.
Hello. Thanks for having me, Ali.
Hello, world. Awesome. No, thanks for coming and helping show people what you can do with Lilypad. I'm really excited to see your piece, actually, because I haven't done an end-to-end development cycle on it. Anyway, so for this workshop, we're going to explore the architecture of Lilypad, how to run a node, how to build a job module, we call them. We're also going to delve into the technicals behind Lilypad, so providing you with a comprehensive understanding of how this operates, or this platform operates, and how it can be used for various Web3 and other general compute applications as well. So whether you're an experienced developer or new to the world of decentralized computing or can't even code, you can use Lilypad. And this workshop will show you how to do that. So let's dive in. Let's get started firstly with what and whys of Lilypad. So open data and infrastructure aren't just an interesting and topical field of study and growth, but to me, how we build or don't build these pieces of technology is really going to be essential to ensuring that we provide equitable access to technology and to the web in future years. And it's a major driver behind the Lilypad project as well. So what exactly does an open infrastructure stack look like, though? What components do we need to build one? If we think about what the modern web stack looks like, it's all about data. We either want to move data around, we want to store data, or we want to make data useful. And these three components, I might just remove you for a second. Logan, you might just feel a little bit weird being on screen and not talking. He'll be back shortly, folks. And feel free to ask questions as I go as well. Happy to answer them. Backup support there in the office, Logan. Anyway, so these three components, networking, storage, and compute, form the basis of pretty much everything that we do in today's connected era. However, compute's really been a bit of a missing piece of the decentralized infrastructure story. So with a few experimental exceptions, and that's probably for a couple of reasons historically. So firstly, there's major complexities involved in building a fully distributed compute network. They're large complexities and the research is actually still ongoing. Secondly, as a space, I just think we weren't quite ready or there yet. There was kind of more pressing problems to solve, like internet scale storage or scaling solutions for blockchains that have enabled this kind of technology as well. And coming from the Filecoin ecosystem myself, I've definitely seen how far that vision has come in the last couple of years as well as how far the L2s and the ZK things have come in the last couple of years too. But this compute piece it's kind of never been more of a relevant problem than it is now, and that's because of this absolute explosion of AI and ML, which is driving exponential demand for compute and for compute resources. And this isn't just demand for training large foundational models like ChatGPT either. It's currently this compute domain is really currently the domain only of large companies with access to vast amounts of data and compute power. For training the foundational models. That's like the domain of them, which is the centralization point I'll kind of circle back on later. But the demand for AI compute also includes running inference models like Stable Diffusion text to image, or running an LLM prompt on some of the open source models like Mistral, or fine-tuning models via LoRa, which is low rank adaptation for short, as well as other emerging algorithms. And it's this kind of explosion of growth of demand that is driving some projects like this as well, at least in my opinion. So anyway, it's also like obviously a fundamental piece of the puzzle stack here. So this is a space and future we're hoping that Lilypad can play a big part in helping to create. And it's a space that I personally have dubbed the now frontier of open infrastructure, because coordinating these global actors in a network and creating these efficient distributed peer-to-peer marketplaces is something that Web3 is really uniquely positioned to provide and incentivize at scale. And like it's something that Web3 has been working on for the last 10 years, and this is a problem that it can really have a good impact on. What happened here? Oh, that's right. I forgot about my animations. Anyway, so what is Lilypad? Lilypad's this flexible, global, permissionless, distributed compute network. It enables internet-scale computing jobs that includes AI and ML workloads, while also unlocking idle processing power and new marketplace opportunities for participants. So in practice, what this means is that we're building a marketplace for compute jobs. So we're aiming to be able to provide more accessible and cost-effective computing power to consumers via this independent global marketplace that uses this distributed hardware network with inbuilt trust mechanisms. So, for example, if you want to run a text-to-image model, then you could do that on our network of hardware, or alternatively, if you have some spare compute, you could put it to use and be rewarded for running it, for running verified workloads for other people on the network. So you'll be rewarded and paid for that. And we want to make sure that all of this is really easy to use on both sides of the marketplace as well. So you shouldn't need a degree in AI to access state-of-the-art open source models. In fact, this should be as easy as any web UI out there makes it. And you also shouldn't need to pay a fortune to keep a cloud GPU running for your own experimental jobs, or just so that you don't lose access to it. So from a Web3 perspective, enabling distributed verifiable compute that can unlock this internet scale compute capabilities, and perhaps even help onboard those next million developers we keep talking about, maybe seems like an obvious thing to do, but there's a few other reasons motivating us as well. So first, we take a look at the current compute landscape. We have a scenario where there's only a few dominant players in the compute and infrastructure market, and this makes for an effective oligopoly on storage, compute, and infrastructure, which, as most folks watching here probably would be very aware, leads to some negative outcomes for both technology and society. And it's these same powerful players, as I alluded to earlier, who have access to a vast amount of data and powerful compute hardware, but also dominate the AI space, and are even now pushing an agenda for regulations that essentially mean that all AI models should be proprietary. So I'm sure a few people out there would have been blown away by the capabilities shown at OpenAI Dev Day. When I wrote this, actually, this was prior to the Sam saga. So I gave this speech in Istanbul, actually, prior to the Sam Altman OpenAI saga. It was just like kind of funny, the timing. But anyway, this was just open after the OpenAI Dev Day as well. So anyway, I'm a big user of ChatGPT. It's amazing for all the things, like writes so many blog, at least outlines for me. It's great. But, and this recent release looked really epic, but I'm wary that what's happening here is effectively vertically integrated AI control. So models and our access to them are either a black box, they're rate limited, or there's other questions on their origin. And what we really need is fair and actually open access to a technology that's poised to like really massively change our society, and already is really. And this quote, by the way, from Yann LeCun, he is the lead at Meta AI, who knew Meta was going to be cool again. But this guy is the lead at Meta AI, and he's a big proponent for open source AI as well. So he's worth a follow if you're interested in hearing more about the arguments going back and forth there. So it's in both these spaces that we hope Lilypad can help provide value and help co-create a vision for both distributed, crowdsourced, open compute, as well as a vision for building this like decentralized, actually open AI stack. So this capability for decentralized AI with distributed compute networks like Lilypad is one of the major whys, because we don't think that one company should control access to scientific breakthroughs. And that's the same for AI advancements or the data sets they're trained on as well. In fact, we think AI has immense potential to provide benefit to humanity, so that shouldn't be gatekept. We should all be able to be stakeholders and owners in this future, and we should all have the capability or capacity to have a say in its collective future together. And that's something that is brought up really eloquently in this Peter Wang talk, this Compute Over Data talk by Peter Wang. So if you want to hear more about that, I recommend giving that one a listen as well. So what's also interesting when we're talking about open source AI, though, is that, according to this leaked Google article or internal article, it's also clear that open source AI and ML is already outcompeting the centralized versions. And that's because they're able to define use cases and fine tune more easily on less data points. So as a person, I'm aware of like problems happening in my immediate environment that or expertise, specific expertise I have that I might be able to solve with AI. And I'm more aware of that than a company that is far removed from that is going to be. So this is why open source AI and ML can win. So they can better, it speeds up solutionizing and innovation in the space. And by targeting this kind of common good better, gives hobbyists access, and people and developers the tools for AI and access. So that's one reason. But this brings up a problem at the moment, which Elon Musk, love him or hate him, has eloquently described here, and that's access to GPUs. And it's a problem even OpenAI is experiencing. It's a global GPU shortage. And what this problem means is this lack of access to GPUs at a reasonable price is a key issue for open source AI and ML, as well as new market entrants to be able to be competitive in the market. Thing is, though, GPUs are kind of everywhere. We just really aren't allocating them to the market efficiently. And this isn't surprising given the centralized nature of much of the world's infrastructure. But this is really where decentralized physical infrastructure networks, or DPINs as they're also called, can really shine. And that's in their ability to create these efficient marketplaces with open participation and fair incentive structures. So kind of not unlike the way that Uber disrupted the taxi industry back in the day with a peer-to-peer model. And Lilypad is one of those networks that we're hoping can help do that. These networks also bring better pricing and global hardware distribution by enabling these coordination layers to match the demand with supply more efficiently and give better marketplace dynamics as well. So to recap that big long spiel of mine, hopefully there's still people listening after that, but I really believe in a lot of those things, and hopefully I really understand the why of this now. But just to recap, in both physical, practical and philosophical terms, distributed compute networks can really provide this host of benefit for participants on all sides of the market, and really help combat those issues of censorship or access or anti-competitiveness, and provide more efficient marketplaces and increased innovation and access as well. And this is also, something I heard on the A16 podcast the other day, actually. This is up on Spotify. If you want to listen to this episode, it gave a really good rundown on what's happening in compute and AI in the Web3 space, AI cross Web3 or /crypto it's called. Anyway. And I really liked this quote from Ali, with the vision being to give a more equitable stake for all parts of this like AI ecosystem to people building in them. And honestly, that's something that Web3 is uniquely positioned to do. So this is why we're here. Let's dig into how we're making it happen, though, the fun stuff, the technicals. So Lilypad's live, firstly. Under the hood, we combine this off-chain compute implementation details, which is derived from a peer-to-peer compute project called Bakuya. And it provides on-chain coordination and verification of those on smart contracts on the Lilypad network and testnet. So it's off-chain compute with on-chain guarantees in a nutshell. It's building Go on Solidity, and the current testnet is running on a Geth local net and uses its own ERC20 token to pay for jobs, the Lilypad token. It's fully EVM compatible, so it will be rolled out to other EVM-based chains in the near future too, with one of the first ones being the IPC testnet, which is the subnet chain on Filecoin. We've also tested deployments to Sepolia and Polygon Mumbai. They're not quite live, but they are able to be used soon, so that'll be coming soon as well. So it's made, Lilypad architecture is modular. It's designed for developer and user flexibility. So while we're targeting AI and ML jobs, you can actually run any compute job on our network. So it starts from the core code libraries, then it adds verification with smart contracts and these services for off-chain market matching in the network is run on the Lilypad network layer. Finally, making it all approachable, we add this SaaS layer for both users and devs to access the network easily, and I'll talk more about that later. So distributed compute networks need some sort of verification. If you're going to have a permissionless system, you need to be able to verify that jobs in the network are getting run as they say they're getting run. So how do you, make sure that nodes on your network are actually running these compute jobs and not just taking the money and saying that they've run the jobs? And this is why you need some sort of consensus mechanism. So it's not like a proof of work per se, but it's kind of like that. So Juan Benet, who's the Protocol Labs founder and CEO, kind of developed this distributed compute triangle that has the types of consensus that can be used in a distributed compute network. Now, the thing is, you want either privacy, verifiability, and performance in compute networks generally. The thing is, when you're doing a distributed compute network that needs verification, you can really only choose two of these. So you can have verifiability and performance, or you can have verifiability and privacy, but you can't have three. So you have to opt for something. So Lilypad has opted for a variant of optimistic with an economic collateral stake model, so a game theory model here. And that is in order to incentivize good actors on the network and discourage cheating and collusion in the network. And this provides kind of for the optimal performance in the network, which is really what we want, while still providing trust and enabling scalability of this network. So reputation-based layers are also out there, but they don't really enable for this scalability, in my opinion. And ZK is not ready yet, guys. So nice thought, but definitely not there for ML and AI yet. Anyway, so this provides for optimal performance, and it also creates these unique market conditions. So kind of creates this job-based marketplace as a feature, which we really like. And in order to provide our privacy, we're going to look into T support a little bit later as well. Like I said, this kind of verification means that all compute jobs on the network need to be deterministic to enable verification. I'm just going to backtrack a bit because I don't think I really explained optimistic reproducibility very well there. What it means is, like, as an analogy that I like to use, it's like a kind of train inspector or a ticket inspector on a train. So if the price of the ticket is low enough and the cost of not having a ticket if you're caught is high enough and the chances of being caught are at like some balance level, then you're going to buy a ticket. That is the best thing to do as a good actor or as a actor trying to optimize their circumstances. You're going to buy a ticket. So that's kind of how optimistic verifiability works. But that also means that you need to be able to check if a job on the network has been run to be the ticket inspector. So there's mediators running on our network that act as these ticket inspectors, and they check a percentage of jobs by rerunning that job to check that the result was correct. A client can also challenge a job result as well. just FYI. But anyway, so that means that jobs on the network need to be deterministic. So this creates this module system or this job-based system, which I was just referring to. So a module is really just a GitHub repo that defines a compute job to run on Lilypad, and developers can use like the ones they've already got available or create their own. But I won't steal Logan's thunder because he's going to show us exactly how to do that later. And they can be either Docker containers or arbitrary WASM there. So that's a module in a nutshell. There's already a bunch of modules, both contributed by the Lilypad team as well as contributed by the community, available to use. So things like SDXL, Mistral, LLM, all available to use. And we're going to get on with, I'm actually going to show you that in a minute as well, or how to use them. And this kind of bootstraps a whole ecosystem as well. This is what's great about the module system, why I was kind of saying it was a feature. And that's because it provides flexibility to users to define their own parameters for running compute jobs and what their job should look like and what they need to run on. It also has the advantage of being able to enable this marketplace of modules where module creators can even charge a small fee to users for use of their modules. So this kind of bootstraps, as I was kind of saying before, we want this like actually open AI stack in Web3. So this kind of bootstraps not just a marketplace for compute, but also an ecosystem of defined compute jobs, or at least we're hoping it can help do that. So there's multiple ways to access the Lilypad network as well. So via a CLI, via smart contracts, via a web UI, and in the future also using APIs and SDKs that will be under development. Alrighty, let's get into the demo. I've talked enough already, enough of the rambling. So to get started on Lilypad, much like any other network, you just add it to your MetaMask or wallet of choice. We're currently running on a Get local net, so these are the details for adding the Lilypad Aurora network to your wallet. You can then go to our faucet and get funds. The faucet will give you kind of both ETH to pay for gas on the network, as well as the Lilypad token to pay for jobs on the network. And you can then and that's really it for installing on your wallet. Once you've got your wallet all set up, you can go ahead and install the CLI in your terminal. So I already have it installed here. Yeah. Or I'll show you in a minute, but hopefully I might just make that a bit bigger. It might be a bit small. Awesome. I already have it installed, so I won't go and do that again. But it's pretty easy to install on the CLI. You can just run these curl commands down there, all documented in our docs. So go ahead and have a look at that if you want to install. There's also a video on how to install it as well up on our YouTube. I've got this was here. So if you prefer video, that's one for you. All right, let's get on with actually using a demo though. So one of the first modules we put on Lilypad as our kind of hello world of Lilypad was this Cowsay module. It's just a little bit of fun and it enables you to kind of test out the network. So I'm just going to run the command. So maybe I can try a different command here. So holiday developer world. You think I'd have better ideas by now, right? But if anyone was following my tweets on this workshop and saw my attempt at poetry, you probably know it's best if I just leave that to ChatGPT. Anyway, so you can now submit a job on the network. So I'm just running this Cowsay module. What's happening here is the job is submitting to the network. It's then negotiating a deal. So it like broadcasts to the network, hey network, there's a job, who wants to take it? What are you offering? Compute providers will bid on that. And this is all based on Backyard like logic, by the way, but not actual Backyard network, but based on Backyard logic. And then once a deal is made, that gets written on chain, so written to one of the smart contracts. People put up collateral for the job, so both the client and the compute provider put up collateral, and then the compute provider runs this job and sends back the results. And those results either get tested or the client can argue with them, or they've just verified or they're accepted. And then the results is accepted. So let's go ahead and see what results we've got from running hello cow world. So this, you'll notice this is like an IPFS CID, by the way. So actually the results do get written to IPFS, but just for ease of use on the CLI, we're also writing to the local file system, so you can open them fairly easily that way as well. And if I open this standard out file, you'll see that there's a hello holiday developer world cow. So that's obviously not AI, but a simple job that you can run on the network or start to build off happening there. All right, cool. I've said cowdy. Yeah, never mind. I'll stick to my day job. Anyway, so what else can you run? Well, how about text to image prompt? We can try this text to image prompt, and I was actually getting a little bit obsessed earlier with making I found these really cool prompt in a blog post somewhere, and I was trying them out, and I started getting really obsessed with how much I could change this purple head image and what it took to do it. So interested in your tips on prompt engineering, by the way, if you have any. So this is the prompt I was using, like a woman in a futuristic suit, hacking on a laptop at a cafe, cyberpunk art, neo-figurative, anime. Maybe let's give her some blue hair this time or something so I can distinguish that the job gets run. I don't know why that quote keeps coming up on me. Clearly, oh, good. And it's not running correctly, so that's always fun also. What have I got wrong here, Logan? Neo is a Lilypad B1 run. Looks good to me. Oh, I know what it is. It's all you can't actually put the commas in. My bad. I forgot about that. It escapes them. So there's something we are going to have to figure out that piece of things. But at the moment, you can't actually use commas, which is what's going on here. So let's try that again without the commas, I think. And it clearly might be using the wrong quotes here. Oh, yeah, because I've copy pasted it. I've got two different sets of quotes on the end there as well. So I might try to fix that. Good old, there we go. Now it's running. It does actually work. This is user error, folks, not Lilypad error. Well, maybe it is. Okay, I'm going to come back to that one. I promise you that was working earlier. I don't know why it's not now, but it's definitely something to do with the prompt, and I'm putting it in incorrectly. Actually, maybe Logan can test it in the background for me, and we'll have send me a prompt that actually works. That'd be great. He probably is already. There is a demo of this as well running on our YouTube, so you can go ahead and look at how I run that. Actually, it might be just the way I put it in. -I prompt env a prompt. What is it? -I prompt env prompt on futuristic C. Fucking alas. That looks right to me. I can't see anything wrong with that. Now I want to know. 0.9. Yep, looks pretty good. Interesting. I wonder what's going on there. Submits the job and then spits out something. So, oh, I've seen this. Oh, I know what's going on. I think, is it working on yours, Logan? I bet it is, isn't it? So I have had this error occur before, and hell, like let's show you what to do if something like this does happen. Actually, might as well while we're here, hey. I've actually had this error happen before, and it's because I just need to clean out my local kind of repo that I'm running off. So if you have a look at the docs, you can go to Quick Start. I think it's in Quick Start. Nope, not Quick Start. It's in Stable Diffusion. So you can go to the Stable Diffusion example in the docs here. It's so white. Usually my docs are dark, so super weird. But anyway. Blah, blah, blah. Blah, blah, blah. I'm sure I put in what to do if something goes wrong the other day. I'm pretty sure it's just I need to clean out my folder, remove one of the folders in my local repo. I could have sworn I put it in the GitHub. That's why. So there's also instructions on the Lilypad GitHub, which are probably more up to date than the docs a lot of the time. So also have a look at them if you're looking for anything. Here we go. This is it. So sometimes it gets stuck on this pathway where it's storing all the images. I'm not sure why. We're going to look into that. But basically, there's like a repos there that you can remove, and you should be able to remake it. And then hopefully this will work. Otherwise, I'm going to look really silly. Let's see if this bug fixing in real time works. Yeah, look at that. I feel like a champion. Just kidding. All right, so it does actually work. I promise. Anyway, how are we going? Probably really late on time already. Let's see what happens with this blue one. That'll be negotiating a deal, running on a GPU, and then it'll send back the results. Just a point here, actually. I'll put this back in. Why aren't we in presenter mode again? Put this back in presenter mode. So just a bit of a point here. You'll notice if you run the same prompt on Lilypad, because of the underlying determinism, you'll get the exact same image back. So if you want to change that, you can change the seed by changing the random seed to another one. It runs at the moment off the seed 42 because that's the meaning of life, yo. But definitely you can change that seed in order to change the output image. So let's see what we got here. Ooh, look at that. Pretty cool. I like it. I think I'll be making more of those later. No. Anyway, I'm not going to get distracted. Like I said, you can change the seed if you want to change the image. If I run that exact same command again, I'll get this exact same picture back. So what else can you do? You could run a large language model. So Mistral 7B is a recent large language model that was open sourced. And whoops, let me just go back. And it's one that you can run on Lilypad as well. We have a module installed for Mistral. What's going on here? You probably don't need my speaker notes, which is basically just to give me the commands that I need to run here. Or in this case, it doesn't give me the commands I need to run. So, okay, I'll just get it from here. All right, so let's try running Mistral now, which is a language model, like I said. In this prompt, I'm asking it name 10 Renaissance artists. Not that exciting, but let's just see how we go with getting an answer for this one. Oops, I have lost all the things. There we go. So the job is running at the moment. I'm making a deal, and then the job will run. And we'll do a lot of making this performance a lot better. So you may be thinking like this is a little bit too slow to be useful in your apps. But definitely we're going to be doing a lot of work around making this. Oh, thanks for sharing those prompts, Logan. I just saw them in our private chat. But yeah, we'll definitely be doing a better job of making this a lot more performant in the future as well. So remember, we're in testnet. We're still testing things out now. But it definitely works. So you can have a look at the YouTube demo of using Mistral 7B from the CLI as well. That is available on the YouTube too. All righty. And next, there's another fun one that I actually wanted to show you that has just recently been contributed by a guy called Fabry, who's part of the community. He's building an application called Dub3 that uses kind of this text to voice protocol, and it's based on an input of, actually I think my next slide shows this better. So basically you put in a voice sample to this model, and then it kind of trains to that voice sample. You can then add a text prompt for what output you want in that voice sample, and it will output a voice based on the original voice sample. I feel like I'm going in circles here, but you kind of get the meaning. Based on the original voice sample with the words that you put in as a prompt. Which is pretty cool. You can even do it in like a heap of different languages too. So it's based on this Cocky AI. Hopefully I said that right. It sounds doesn't sound right, but it definitely is. So it's based on that as well. So this LLM model has finished running. So I'll just quickly verify for you that it did actually work. If I have a look in standard out, I should have a out. Oh, I guess. Okay, something went wrong. Oh no, there we go. So here's my artists here: Leonardo da Vinci, Michelangelo, Raphael, Titian. An important Venetian painter. I don't think I've ever heard of him. Botticelli. Yeah, all the well-known artists there. So that's how you would run Mistral on the CLI there. Pretty cool. So now let's try out this text-to-speech one. I'm just going to click my up arrow like a million times because I was using this a little bit earlier. So what I've done is I've recorded a sample of my voice, just what everyone wants, a sample of this random Australian talking. And I've uploaded it to IPFS via Web3 storage. So as a WAV file, WAV file is that called? And now I'm going to run this module. So you can see kind of the logistics of running this module. One of them is the location of the module. It's just a GitHub repo. Then the URL link to the voice recording that I uploaded to Web3 storage. Then the text that I want the voice to output. The language to output, so in this case it's English, but you can have Italian, French, lots of other options. I think 10,000 or something options. You can have a look at the GitHub for everything that's available there. And then here's the Lilypad folder settings, so where is this going to output to? So I'm just going to, let's see, this says, hello, you're listening to voice translation on Lilypad with Dub3. So I'm just going to run this one. This is a funny one because there's a voice to output. I don't mind the pictures, but when you hear your own voice back at you, it's a little awkward. But we'll show you that in a second. So there's also other things you can do, obviously. So another module example is LoRa. So fine-tuning a module, and that, again, you can add input from IPFS, for example. So you could add, say, 30 images of Claude Monet paintings and fine-tune an SDXL module to output images in the style of Claude Monet, for example, without you even having to ask for the style of Claude Monet in your prompt. You could fine-tune the model to that. And then you can use that fine-tuned model so we use IPFS basically as a storage cache here, that you can use that fine-tuned model then to output, like, this photo of a dog, for example. It's not a very good example, but you could do something then with this, like we did with Waterlily AI, which I'll come back to. This output is ready for me. So come back and let's see what voice output we got here. All right.
Hello, you're listening to voice translation on Lilypad with Dub3.
Yeah. I should probably record a longer sample and it might get a bit more Australian, but it's not bad, right? Like, considering this is an out-of-the-box text to voice, you could play around with the parameters and fine-tuning this model a bit more, and it could get really interesting, especially if, yeah. Anyway, so kind of fun, actually. So big thanks to Fabry from Dub3 for contributing this one to the Lilypad network as well. Like I was saying before, LoRa fine-tuning, so fine-tuning to a particular art set, is what we've done in Waterlily.ai. So Waterlily is kind of this proof of concept application that we made. It's a generative AI art platform that addresses kind of some of the key issues around attribution. And it really shows you what you can do at the AI crypto intersection, or some of the problems you can solve in the AI crypto intersection as well. So it addresses some key issues around attribution, for example, of artists. And it does this by enabling an artist to kind of upload their sample images which are kept fully private. And then a model is trained to their sample images. An SDXL model is trained to their sample images. And we did this a while ago, which is why maybe you're thinking these images don't look, oops, sorry, just maybe you're thinking these images look a bit not great, but it's because we did it a while ago on an older version of Stable Diffusion. The open source versions are just like wildly good now. It's kind of amazing how quickly that's occurred. Anyway, the point was you fine tune a model to that particular artist's style, and then a user will come in and pay a small fee in order to generate artworks from in this artist's style with Stable Diffusion model underneath that. And those fees go directly to the original artist, or at least a percentage of those fees. In this, all of the fees go to it. We're paying for the network. We're not taking any cuts. But you could imagine, like in reality, you kind of pay a percentage of that fee would go to the compute, and a percentage of that fee would go to the artist, and a percentage of that fee would go to the module, and then all of a sudden you've got this really open AI ecosystem happening. So this is one example of how you would use one of these models in your own applications as well. So I'm not going to go through this, but you can also use Lilypad directly from smart contracts. So basically what you do here is you would implement our interface in your smart contract code. It needs to be running on the Lilypad network, obviously, or one that we've integrated with, which is why we're going to integrate with multiple networks. You'll be able to run these compute jobs from multiple EVM networks across Web3. And there's some example code here in the GitHub if you want to see exactly how you would run from a smart contract as well. There's a tutorial coming out on that soon as well, so keep an eye out for that. Also, one thing I haven't mentioned, I've said a lot about what you can do on the Lilypad network, but what if you want to contribute your resources to the network? You can also do that. You can run a node on the network, bring your GPU to the network. We actually have opened up a calibration test phase that you can join. So if you are a GPU provider, please get in touch with us. There's a form at bit.ly/join Lilypad CalibNet, or get in touch with me on any platform that you can find me on, and that will be moving into an incentivized testnet that will collect rewards in the new year as well. So if you do want to run a node, have a go, give us some feedback, join the calibration test phase for that. Alrighty. One more thing. I forgot about this slide. What if you want to run Lilypad in a front end? Well, you can also build a front end to run on Lilypad. And a guy called Jay, who's been helping out with the Lilypad project, has written up this amazing tutorial and code base for how you would run Lilypad from our front end. You can go to our blog to find all the details on how you would run from a front end as well. Sorry, not from a smart contract. This one's the front end. So if you want to trigger that and you put your own module in, it's kind of like a good, what's the word? It's like a good starting point. It's a boilerplate for running your own front ends or developing your own apps here. All righty, Logan. I think we're on to your part of the demo here.
Awesome. Can you hear me?
Yeah,
all right?
I can hear you very well. I'm really excited for this because you're going to show us how to build your own custom module on Lilypad. So I'm going to shut up. Do you want me to? I'll remove my screen and add yours to the stage. And we're good to go. Take it away, Logan.
Thank you so much for the awesome intro. Lilypad, as we've heard, really awesome enabling project. I'm very excited about it. I think a lot of people everywhere are. Being able to have my own graphics card compute jobs for people all around the world and me make money for it seems like something out of the future. And so being able to actually do this in real life and do it myself, you guys are about to watch, it's actually so much fun. So yeah, let's just get right into it. Ali, you talked a little bit about kind of the biology of a module on Lilypad. And so I'm going to go through, I guess, a little bit more. And so I'll be going through a module overview. Second thing on the agenda, we're going to find a module to use. I've already found one and downloaded it. And so we'll be kind of going through that rather quickly. We're going to set up our Docker and build our Docker file. And then we are going to try and submit our job to Lilypad, the new job that we create. And so let's just jump right into it. So great. So basically, a Lilypad module is, like Ali said, a way to orchestrate jobs to the Lilypad network. And so as a developer, I can build a Lilypad module and put a model that either I created or somebody else has created, an AI model, ML model, or just a particular job, like you would put on a serverless dedicated serverless server integration. You could set it up like that. So the way you do that is with a collection of 4 files. The first one, probably my ideally most important file is going to be your load model.python. So each model you're going to be working with is going to require a different runtime. And so since I'm working with one that allows me to use Python, that's why mine load model.py is Python. So be wary of what you use. I'm familiar with Python, so that's why I chose to use it. Secondly, you got this Docker file. That is what, of course, you build your whole module into, and I'll be going over how you bake a model into your Docker file in a little while. And then your requirements.txt is just a collection of dependencies that you need to add into the Docker file. And then lastly, you have your Lilypad module json.tmpl, which Lilypad will look at to basically run the job that you want to do. And so right here, I've got an example of a very simple ML model. The one I'm decided to use is called Phi2. We can go to Hugging Face to go and look at it. And so here's Hugging Face. Everybody knows Hugging Face, hopefully. Phi2 is here. This is from Microsoft. It's really awesome because, as Ali said, these open source models are just incredibly well built. And so taking advantage of them and making use of them is like hyper important, in my opinion. Everybody's, I think. And so I wanted to try this out, see if I can make this work. Let's try. So this is a version that I've got working already previously, and so we're going to be working off of this. Hopefully, I'm not going to be too quick about explaining everything, but like I said previously in the slide here, we've got our 4 files. Hopefully, everybody can see this. But yeah, I've got these 4 files here. In our Docker file, actually, I will go through our Python file first, because this is what actually this is the meat and bones of what we're trying to do. So the first thing that I put in my Python file, everybody should put, and of course, I have examples here that I used within our presentation too. These are examples that the community and Lilypad has already come up with to help us. So Hugging Face Hub is an import that you need. Super important to download your model. Like I said, you need to go find a model on Hugging Face, and you put that model, whatever model you find, you put that here. And so here I have the snapshot that I need to use from the gentleman that has come up with this model. I tried to use this Microsoft model, but it was really, really finicky and specific. And so I found this a Phi2 model from somebody in the open source community that people liked, and it worked really well for me. So I decided to use that one, if anybody's curious about that. So yeah, the model goes here. I was curious about how that worked. That's pretty simple. And then this is where we get into the actual ML AI stuff. So this is like actually loading in the module into whatever computer we're talking to. This is a statement to basically tell the device, hey, if there's a GPU attached, use it. If there's not, don't. Just so we're aware, a disclaimer, none of this is probably perfect or correct or well done in any way, but it works really well and you can depend on it. So that's just a little disclaimer there. I'm sorry, I should have had that at the beginning. So yeah, so this is that we're working with an LLM. So I should have maybe mentioned that Phi2 is an LLM from Microsoft. There are two different versions. There's a bigger version of the model, and then there's a float 16 version. And due to me I wanted to test the model locally. That way it's easier to send over to Lilypad. And so that is why I'm using the float 16 version, which just has lighter weights and it's easier to load into a graphics card. You don't need as big of a graphics card to load it in. So great. I hope that explains really all of this. Okay, moving on. Like I said in the requirements, there's a lot of dependencies that you're going to need. These dependencies are laid out. They're always going to be laid out in your Hugging Faces or your models documentation. So in this case, it's right here. I don't think I added any. I did add bits and bytes for a reason I don't quite remember. But depending on, the thing is, when you get your Docker container built and you run it, whatever errors you get, you're going to have to work through. And so I believe I needed some of these to move around those. You of course need Torch for PyTorch. I'm using Python. So yeah, great. I went over this Python file, the dependency text file, great. And then now I'll go over the Docker file. So this is what actually gives Lilypad the instructions to run in more of just like a file format. So like, hey, use these directories to run this stuff. These are all seem to be pretty simple and pretty straightforward. Let's see if anything specific that I really had issues with. I think, yeah, all pretty straightforward. This right here, the official runtime, each base image for your Docker container, everybody chooses different ones. Since I'm using Python to run my model, I chose to use that one, but a lot of people choose to use NVIDIA container base images, and so that will vary as well. I say just use whatever works for you, but I think it's important to tell people that you don't need a specific one. It seems as if Lilypad's runtime is very docile in what you use for the most part, as long as it's built for Linux specifically. But other than that, you can use quite a lot of different base images. So lastly, sorry to be so boring. So lastly, we have this really important TMPL file. And so this is what Lilypad uses to orchestrate everything, from my understanding. And so this machine string right here just talks about, okay, like these are how much resources I need to use. This is all pretty much the same every time, depending on whose version you're looking at. Everybody pretty much sorts like this. Then we move on to this job right here, which everybody uses this V1 beta 1. So that's I assume everybody uses the same, so I did too. And then we move on to our Docker configuration right here. And so it tells us where our environment variables are. Pretty simple stuff. The output directory for IPFS. Cool. And then, yeah. We just go through some estuary stuff for the network, and then just some more very, very simple stuff, not really too much you need to do there. And so after that, we're done with all, really when I built my Docker file for the first time, I didn't even have this TMPL file finished. And so you can do this at the beginning or the end, it doesn't really matter. I chose to do mine at the end. So to do the actual demo, I've got an empty file right here. It's called clone /py2. And so what we're going to do is going to propagate it with everything we need and do our builds. And so that way you guys can see what we need to do. So first thing I'll put in here is a Docker file. And since I explained to you everything beforehand, I don't have to explain it again. I'm just going to copy and paste all of this. We've got a Lilypad module.json.tmpl. So like I said, you don't have to do this at the very beginning. I wanted to get my Docker container actually functioning first before I did. So that's up to you.
Can you zoom in on that a bit, Logan? Just
Sure. Which one? This one?
Yeah, whatever you're using.
Okay.
Command or Control plus.
Right. Okay. Just let me finish copying my stuff over because I think I have to restart my VS Code to do it.
Oh, no worries. Just a bit tricky to see otherwise.
Yeah, I don't know why this one. I mean, yeah, this one, it's actually, the font is big, but the UI font is tiny. It's like, what? Sorry about that.
You can't just do a Control plus or a Command plus to zoom in?
No, that's like, that would work, I think that works if I'm in this right here. So like if I go into my settings and say, oh, let's up this.
Okay.
Well, maybe it does load. Oh, it did. Okay. Oh, it did. I don't have to reload anything.
Might be a bit better. It's still looking a bit fuzzy, but
yeah,
maybe a little bit. Thanks.
Yeah, sorry. I think Slack, or I don't know which broadcasting service has it to where you can you can decide what part of the screen you want to view. I think that would make my situation perfect, but sorry about the terrible. So okay, so we've got all of our stuff in here. Now what we're going to do is we're going to actually try to run our builds and stuff and try to make sure everything works the way it's supposed to. And so I've got my little things here. So I don't know if it's universally known, but I didn't know off the top of my head what every single command was we needed to do this. And so I just tried to, I think I'm going to get them like tattooed on me after the fact, just because it's so helpful to memorize. But the first thing we're going to need is your Docker build. You have this /t, and then you're going to put your repository name. So my repository name is called clone phi2. It says the Docker file cannot be empty. Well, why is my Docker file empty? Oh, I didn't put my stuff in there. Wait, no, maybe I didn't save it. There we go. Cool. Okay, so it wrote my Docker image. Great. Usually it takes a while, so that's why I'm a little surprised. Okay, so it ran the Docker thing. It built my Docker file. Great. And so now I think I can just try and start testing to make sure it works, if I'm not mistaken. So I've got my Docker file built. Cool. I've got to change the name. Okay, so I'll explain this this string right here that I'm using to pass to it. So this string right here is a really, it's what we've been using in Lilypad. It's this Docker run /GPUs all string. Basically, it just tells this GPUs all right here is only ran locally. So right now, since I'm testing my image, I'm using this GPU all. Basically, it tells my NVIDIA use all the GPUs on the system. But like I said, you don't have to use this when you're passing it to Lilypad, but you do have to use it now. And so let's see if it works. Cool. Wow. It actually is working. Okay. So, wow. That ran really quickly. Okay. So I asked it the question, hey, what is the acceleration of Earth's gravity? And it returned me with the acceleration of gravity on Earth is 9.8 meters per second squared, which is, if anybody's taken physics, they know that that's like the golden rule of physics. So it works. Great. So it works locally. That's the thing. I'm not pushing it to Lilypad yet. So there's a whole lot of steps we got to do to push it to Lilypad now, and I will take us through it. Okay, so the first thing we're going to want to do, whenever you went and grabbed your testnet ETH, you basically have that sitting in your MetaMask, and you're going to need to add that private key to your terminal instance. There's a lot of ways you can do this, but I just run this simple script that says export Web3 private key. And so that works for me. But a lot of people want to use like permanent solutions, and that's fine for you. But there's a lot of ways you could do it. I choose to do it like this. I'm curious what everybody else does, but great. So now we have our Docker image. So normally I would.
Sorry, Logan. Before we start on that, I think we're still having a bit of trouble seeing the screen, so I'm wondering if we can maybe fiddle around with that before we start trying to deploy to Lilypad.
Okay.
See if we can get it optimized.
Definitely.
Yeah,
Okay.
and variable solutions.
It would take like 5 minutes.
Yeah. It must be because you have this like ultra wide screen. Can you not in StreamYard just share one part of your screen either?
You know what? That's probably a good idea.
Maybe try it.
That's probably a good idea. Yeah.
See if it works. So I assume you're going to be mostly working on VS Code. So
that's right. I should have maybe done that. Okay, can we see that a lot better now? Cool.
Yeah, that looks much better. Definitely much better.
I should have done that from the beginning. I'm sorry. I should have done that from the beginning.
Totally fine. All good.
Okay. So great. So I exported my private key, and now I have this Docker file, and it's roughly 10 gigs heavy. It's rather large, and so I need to push that over to Docker Hub. And so to do that, let me switch my thing here. Go over here. Okay, so I have my Docker Hub right here. This was like hyper important. I didn't really have an easy time understanding this. And so each Docker image that you're running on Lilypad needs to be publicly accessible. And that's pretty obvious from the get-go. So basically, there's a lot of ways you can make it public. I chose to use Docker Hub. It's free, and they give you three images that you can push of any size. And so these files are pretty heavy, so finding a place to put them can be somewhat troublesome. So I did the easy way around it. Great. And then the second thing you need to do is you need to add the repository that you just built to GitHub. And so as we know, that's very easy to do. You just go to your GitHub, go to repositories. Go here. I have already created a repository. So then what we're going to do is we're just going to upload our files to it. Great. I'm sorry you guys can't see this, but just the files that I just made in front of everyone. Great. Commit changes. Okay, so this is like a super big brain moment that you have to have when you're working with Lilypad, and so I'll share it with everyone. So I pushed everything to GitHub. You need that. Hyper important. Okay, sorry, I was getting off track a little early. So after everything's pushed to GitHub and you have your image on Docker Hub, then we can go back to our VS Code here, and we can actually start trying to push this over. And so let's get there's a few commands that you're going to need to push this over to Lilypad. The first one is, of course, going to be exporting your private key, whatever that is, and then installing Lilypad. Of course, you need to do that. That's all already done for me. And so the second command that you're going to need, fourth command, whatever, whoever's keeping track. So this command is going to push everything up to Lilypad. So it's actually really simple and really cool how it works. Basically, you just tell Lilypad where to go and what to run. And so, I'll deduce down what exactly all this stuff is. We have a a module repo. So this was the old repo that I made, and so now I'm going to change it. It's going to be clone, and then phi 2. Cool. Okay, so that's just the repo that you have to upload your module into. Cool. So the big brain moment that I was talking about that took me a little while to figure out was this module hash. And so it's pretty simple, I think, if you're smarter than I am. But what it is it's the hash from the GitHub push that you did. And so this is a super important way to keep track of what code is running when. And so the way you find that is it's just if you go to your GitHub, I'll show you by switching my stuff again. Sorry. If we go to GitHub, up here in your hyperlink is going to give you this hash right here. And that's, I guess, it's just Git keeping track of what commit this is. And so you need to copy that. And that is what is used in your string that you pass to Lilypad. And so by switching my stuff again, we can put that string into this. So we've got phi2, my GitHub repository is good. Now we have module hash. I'm going to add the commit hash from my GitHub. I hope that's right. Great, cool. And then module path. This is to, of course, the Lilypad module.json tmpl file. And then you have the prompt that I'm passing to my LLM asking it my question. And so let's see if this works. Wow. Wow. I'm surprised it worked the first time. So we've submitted the job. We're running. It's rather really quick. How quick it works is pretty cool.
Paste the command for me, Logan. I want to paste it in the chat.
So yeah, great. Our job is completed. Okay, and it took me a little while to find the IPFS file that downloads, and so I have it sitting right here. Acceleration of Earth's gravity, negative 9.8 meters per second squared, like it should. So this is how we run a module on Lilypad. It's a lot easier than you would think. Orchestrating this network is rather simple. And like I said, the Docker the orchestration running these Docker containers is rather docile. So you don't have to give it the same parameters for, the same model. You can have two models that are the same, and you can have different parameters for both of them, and they still run correctly, which I find pretty awesome and helpful. So any questions, Allie?
Yeah, that is epic. So basically, we can find any model that we want to run on Lilypad on Hugging Face, for example, or any model that's out there and already Dockerized, and kind of just add a layer to run this on Lilypad. Is there anywhere we can find a tutorial on this, Logan?
Right here, actually, right here would be one. But I definitely want to make definitely we will, in the next day or so, we will have a tutorial that isn't consistent of tiny text. That's for sure.
Yeah, apologies for the screen blurriness, folks. I didn't realize that we were capped at 720p here as well, so that made it a little bit hard to view your screen initially. But super cool that you got up and running with a whole module basically in all of 10 minutes. How long do you think it would take you to run end to end? Now that you know how to do it.
So I'll be honest. I'm not one to sit here and say I was smart, but I had no idea what I was doing getting into this, Allie. I think you knew it. And I've got fully caught up to speed, asking a few questions in the Lilypad chat, getting some help. But I got fully caught up to speed in 2 or 3 days on what to do. I had an idea of how it was done, but the specifics of what to do, it was very, very quick just learning the basics of it, because I didn't know the basics. But I mean, if you wanted to start a whole new module, I could probably do it within like an hour or two, as long as it wasn't like the larger models with more VRAM needed. The way you chunk it into the cards can be very different. That can take longer. And so even with some of this Microsoft model, I was using the larger version, and so I was chunking it into my card differently. And so just switching it to like they have this float 16 version that's like hyper optimized. It was like instant. And so it just depends on how like deep and crazy you want to go. You had me working on the video diffusion, and that one was a lot heavier.
I know that video diffusion one looks so cool though. I saw Stability AI just dropped their latest version of like image to video, their 2-second video. I mean, it's just crazy how fast this is all moving as well. So being able to run them and like get it up and running in like an hour is pretty good, I think.
Yeah.
And then
for like a marketplace, I feel it's really going to shine in the marketplace, actually.
Yeah, awesome. Hopefully. Well, thank you so much for sharing all that information. Now, I think we didn't touch on determinism in this model. Did you make this model deterministic at all?
I did. I totally forgot to mention that. Yes, if you run these, so I can run it locally. It's one of the things that I was a little scared about. I didn't know if it was going to like be deterministic the whole time, but if you run, that's one of the reasons why it was good to run it locally, because you can run it over and over again and you're not tasking an outside network to do it. So, but yes, determinism. I feel like a lot of models are pushing it. Ali, what do you think?
What do you mean pushing it? Pushing determinism or?
Yeah, like a lot of the models I use just out of the box are deterministic in that they give the same answer every time.
Mm-hmm. Yeah, I haven't gone through and played with them, but a majority of the AI and ML jobs actually can be made deterministic. And there's a great write-up on Hugging Face about how you do that for Stable Diffusion, and it talks all about the seed inputs for these models. And how you go about, kind of stabilizing Stable Diffusion. Sorry, no pun intended there, but how you go about making that deterministic. So maybe I'll post that up in the chat in a second as well, for people if they want to dig deep in that. I think it's actually in our docs too. There's a section on how to go about making things deterministic. So it's good to know that it didn't pose a super big problem for you though.
Yeah, I was worried about it, but it wasn't something to worry about.
Awesome. Well, thank you very much, Logan. We're going to work on getting this module that Logan just shared fresh out of the box. It was like, what do they say? An industry sneak peek, basically. We dropped it here first.
Yeah.
Whatever.
Demo time.
However that goes. It's
Right.
like our own version of a dev day, right? Hey, Sam, good to see you. Sam's just joined the chat, obviously. She's been helping out with some of our socials and doing an amazing job, so thank you so much, Sam. But we'll be putting this documentation on how to run this module up in our docs shortly, and we'll also be writing a tutorial on how you go about writing your own module end-to-end as well, so keep an eye out for that in our blog, and we'll post it on Twitter too, no doubt, as well as maybe some shorts from this segment into a like more laid out video on what to do. But massive thanks, Logan. That was amazing. So good to see that. And like you went through it in like 10 minutes, and an hour end to end is pretty good. So thank you for sharing. I'll kick you out now.
Thank you.
Thanks. So, amazing, like making your own module that like opens up the possibility for so many things you can do here. And it's not just AI and ML either. I should mention that you can run any kind of compute job on the Lilypad network too. So as long as it's deterministic, you can run it. It doesn't have to be AI and ML. It doesn't have to need a GPU either, like you saw with Calsay. Obviously, that's the idea. You want to be able to run those fantastic models on the network as well. I do want to mention though, if you aren't a developer, you can also use Lilypad. So you don't need a degree in AI to access this kind of state-of-the-art open source models for your next app either. And we've made it easy. with the introduction of Lilypad AI Studio. So Lilypad AI Studio is basically a web UI. You don't need a wallet, you don't need a private key, you don't need to know anything about crypto economics or how blockchains work in order to use Lilypad with Lilypad AI Studio. So this is a web UI. Basically, you sign in with a Gmail or similar social sign-in, and you can then pay for credits with Stripe. At the moment, it's all free, free to use, free to try, all completely free. It's at app.lilypad.tech if you do want to go ahead and try it out, and we'll be adding more modules as we go here. In future, there'll also be API keys here for devs to use as well. So you'll be able to like put an API key basically in a front end and go ahead and just use Lilypad that way as well. We're not quite there yet. We've got a bit more development to do before we get to that phase. But yeah, that's the idea behind Lilypad AI Studio. Go ahead and try it. Tweet us your results after lilypad.tech. You can play around with prompt engineering there. You can tweet us your creations. We're on @lilypad.tech. Show us what you make. We'd love to see, and we'd love to see more modules being built as well. If you want some inspiration, you can go and have a look at our docs for all the different projects that folks have built on there. And it goes from DeFi to gaming to, there was a map making one, to decentralized Hugging Face just got made. Dub3, like I mentioned, using that voice module there. There's heaps of different ideas for things you can do with the Lilypad network. Someone actually put a DuckDB module on a previous version of Lilypad. We need to update that, but you can do things like that with the network as well. We'd love to see what you will build as well. Let us know. We've also got a discussion forum. If you have any questions and you don't want to join our Slack, it's the best place for instant help. But if you don't want to, there's a discussion forum, so you can hop on there, read some of the old questions, or ask a new one as well. And of course, all the socials to get in touch with us at. We're in the Backyard Project Slack at the moment as well, because we worked very close with that project when we were initially spinning out Lilypad, which is why we're still like kind of in the Backyard Slack. That's where our community is, so please join us there. Docs, of course, docs.lilypad.tech, blog.lilypad.tech, and the website as well. Looking forward to seeing what you all build, and massive thank you for joining our live stream today. Hope it was useful to everyone. Thanks again. Cheers.